set a separate meeting with me. We will talk about it. So EC5011 is the thing. And we had introduction. We saw about what is a system on a chip, how is it made. We saw a video on that. Then we had introduction to Verilog yesterday, and we are getting the actual course today. Okay. So VTTD is VLSI testable. I don't know whatever. VLSI testing and testable design. I call it as a DFT for short, design for test. But that's what industry calls it, right? So we'll use both are same, VLSI testing and testable design. So it's a design for test. And if you don't know how to design, you cannot test it. So that's why I showed you how to design and how to verify functionally, right? That's extremely important. If you don't know what is design for test, if you don't know how to design, how can you test it, right? So there are gaps. So you'll find some surprise elements. So I don't know what to do with it. This is a master's course. Unfortunately, unfortunately, I don't know how many time can answer. The bachelor students are coming, third year students. So it's been designed for a master's course. So 5-level course. You know what is a 5-level course in IIIT, right? Now you are people are in 3-level course and 4-level course. So 2-level up. So the bar is always high. But as I told, I'm going to lower the bar. So unless you ask questions, I'll not know. You have to visualize as you spoke. And you have to ask questions. The online meeting. Unfortunately, we are not going to meet every day. Ask questions to me. Ask questions to Asha. Right? Use a Telegram channel. Right? That's only one way. Or set up interactive meeting. Or one of the class, the lab hours, maybe make an interactive class in a session. Provided I have time, can ask questions. Try and reserve one part of the lab just for Q&A. And we can do that today afternoon, 2 to 3, we can do that. But you lose the lab hours. So you tell what you want. No? There are various options I can do, but I can spend only 6 hours a week. And as I said, next week, Monday, Tuesday, I'm not available. I'll send a recording session today. I'll make a recording today, tomorrow. That'll be on the YouTube. So you can watch it. Right? So we'll get started. So the reference material, you can use it, the textbooks. But I may follow, I may not follow. So don't blame me. Look at, there must be, you know how to get this sort of textbooks. There must be library. 3 textbooks. There are 2 fantastic YouTube videos. You must see them. All right. So there's a lot of things. And you should see the NPTEL Verilog course before that. That's the first primary thing, right? You should see that. That's a prerequisite for this course. Verilog design. If you don't know how to design logic design, and you don't know what is Linux, and you don't know what is Verilog, you cannot do this course. Yeah, feel free to drop out from this course if you think your body is right. But I'll make you comfortable. But I have only 6 hours a week, 6 to 7 hours a week, mostly online, right? So keep this as a reference. So let's get on to the crux. Right? So what is this introductory test class? What is testing? So who wants to answer? You have 45 minutes to go. What do you understand by the name testing? You can read this or you can imagine, visualize and tell.
Set of steps to ensure whether the functionality of the system is working out correctly or not. Like it is working as per the functionality.
No, wrong answer.
So testing is done on a prototype to ensure that it is actually following its ideal behavior or not.
No, same as the previous answer. Not acceptable. Yeah, this is a concept of the entire course you understand. Behavior is something called functionality. Testing is different. We'll soon see what is the verification, what is testing. They are different, you have to understand. Read this slide, it actually has the data for you, right?
Testing is a methodology to check there is no manufacturing defect in the particular chip.
Very good, Shankar. Very good. So that is the objective of this course, right? You make a chip, right? We know what is the system on a chip we saw, right? You all know what is a chip. Not the eating chip, Lace chips. It's a real chip, right? Silicon, right? So you manufacture the chip. How do you know it works or it doesn't work? So yeah, any one of you answer. I'm going to answer this indirectly. You manufacture a chip. Right? How do you manufacture a chip? Who manufactures the chip?
The fabrication industry.
Yeah, who's the fabric? Can you tell me your name?
TSMC.
TSMC, the global foundries.
Very good. And there are a lot of manufacturing initiatives happening in India. If you are following my LinkedIn on India Semiconductor Mission, 2 weeks back, Prime Minister was in Ahmedabad for an event regarding India Semiconductor Mission. So there are fabs going to come up in India. There is already one fab in India. Do you know where it is?
In Gujarat, it's like
Gujarat, they are planning to invest, it will take years. Vedanta, Foxconn, HCL, many people are working on fab ideas proposed with government. They are investing, right? But it will take time and effort. So it's going to take a long time. But already there's a fab in India. If you want, we can go there and see. I'm going to go to Delhi sometime next month. I'll see if we can go there. There's a plant called Semiconductor Complex Limited. I don't know what they call it. It's not a mighty department, electronics department. In Chandigarh, there is a fab. Okay. So that's a good idea. So I'm planning a trip to Delhi in sometime in the end of September. Let me see if I can go. Chandigarh is not very far from Delhi. Let me see if I can get a connect and go there. Okay. Okay. So you fabricate a chip. Then how do you know it is working or not working? What will you do? You buy your phone from the shop. Let's step back. Let's go to system. You buy your phone from the shop. How do you know it is working or not working? You buy your iPhone, let us say, right? Costliest phone. 85,000 rupees, right? I bought iPhone last month. iPhone 14.
We will physically check, sir, like check for the like if it is physically it's okay or any defects is present.
Okay. Physically, or what else will you do? Is that enough? 85,000 rupees you're investing, right?
Then we will power on and check, like use it and check.
Very good. Power on. What will you do after that? Come on, guys.
Run some built-in self-tester, like.
What is the built-in self-test? You're taking a phone. Don't go to American system. You're going to your iPhone shop, Reliance Digital or any shop. You go to a mall, any shop, you Chroma or wherever. Right? You go and you ask for an iPhone 14. You're getting it. You're with 64 GB RAM, 128 GB RAM, whatever. Highest end phone. I know it's 85,000 rupees. I bought it 2 weeks before. Right? So we'll pay 85,000 rupees, swipe your credit card or GPay and come with the physically checking the phone. Will you do that? I'll not do that.
So we'll randomly try to run some apps and check whether everything's working fine.
Very good answer. Very good, Vikrant. So we randomly run some apps and check it is working or not. First, there's a boot. You power on the phone, display comes up, right? Wi-Fi comes up, correct? But they may not allow you to set up the Google. So you have to look for a demo, please. To do something, right? iPhone will work, but you have to do some amount of testing. Understand the word testing, right? You do some amount of testing. Testing you do on a product. Okay? So you do testing. So iPhone, what does the iPhone contain inside the phone? I showed you the system. I'm making the first video, right? So what does it contain inside the iPhone? We rip open the iPhone. I don't want to take an older iPhone or any cell phone. Old phone must be the non-working condition. You open it up and see what it will contain. I think you should do that. Being an engineer, I would recommend a non-functional home. Don't break the iPhone. Any non-functional phone at home, open that and do a reverse engineering. Do piece by piece. You have to do it. That's the best way how you do engineering. Right? You want to build a car, you should use a nut and bolts, or take a bicycle. Right? You should remove all the parts of the bicycle. Remove all the wheels, spokes, handlebar, nuts, bolts, everything. You remove it. Right? Remove all the parts, minute, small as possible. Remove it. Assemble it again. Put it back. That's how you learn engineering. That's mechanical engineering. Similar in electronic engineering, you take any non-functional electronic product. Let me be very clear. Any electronic non-functional product, your mobile phone or a TV you remove everything. Remove the small sort of particle. Take out everything and see and understand what does it consist of. Have any one of you tried that? Anyone want to try? Please raise your hands. How many hands go? Asha, can you check how many hands went up? 3. Wow, 4 high hands. Asha, write down the names. I see 1, 2, 3, 4, 5, 6, 7, 8, 9. Very good. Fantastic, guys. So do it as your hobby. Take care of academics, take care of your hobbies, wealth and everything. Then you do that. You don't have to report it to me, but if you're interested, yeah, we can discuss that. Okay, very good. Right. So that is the testing. Right. You post manufacturing. iPhone is an example. Take the phone out. Right. You test it. Right. Undergo the test of testing the actual chip or a product. Right. Right. So that's how we test. So typically, what do you mean by defect? What is it?
Some anomaly.
Something that requires a replacement, sir.
No, I already given different examples here on the screen. Look at the bottom
Any
of the
fault
slide.
or mistake, sir?
What is a fault? Come, you are falling into a trap, and I love this. Please, the important concept. Please make notes. As if every class we should write notes. What is a defect? What is a fault? Very good, man. Very good interaction. I love it. There is no right or wrong answer. Please answer. Your answer. I want your answer.
So defects means it's manufacturally mistaken. Fault means that defective items will get noticed as the good product.
No, first part is correct. I don't know who answered it. Second part is wrong. Yeah, raise your hand and answer it. At least be able to see. I'm looking at it. Waiting. You're talking. Raise your hand and ask. At least you know who's talking. Okay, first part is correct. Defect definition is correct. Fault is wrong. Don't worry, we'll see what is that. Okay. So, what is the type of defects? Broken wires. You know what is that? What is a broken wire? What is a wire? Raise your hand and talk.
It is an interconnect.
Very good. What is interconnect?
It connects two something, sir.
Very good. Two components it connects. Connects the two components called wire or interconnect. Very good. Right? It can be PCB, breadboard or whatever. Right? And what is the wire interconnect? What is a broken wire? Raise your hand and talk.
Circuitry, sir.
So the link between the electrical components are broken, so the circuit won't work as intended.
Very good. Broken is a disconnect, right? Because use simple English, understand, right? The two wires are disconnected. So when you manufacture that particular, or you take your breadboard, you use breadboards, right? In the class, you're in the second year, whatever design is in lab, you use a breadboard or you put a jumper wire and connect them. What if you don't make the connection correctly? That circuit will not work, right? Using 74LS04 and wiring with 74LS 74 whatever, right? Some two ICs you are connecting together with a wire, a breadboard. The wire is not making proper contact. The logic system will not work. Have you seen such a situation in the lab? Raise hand. Okay, you've not seen it, seems okay. So you should try it out. That means you've not done your lab correctly. Have you worked on have you tested any of the PCBs? Printed circuit board. Have you seen a PCB?
I tested only IC, sir.
How do you test IC? Very good. Happy that you tested.
We are given some ICs. We are given a board. I don't remember the instrument name. We used to keep it at the bottommost part of that board. We used to lock it, and then we used to give some entry, and it used to give whether it's working or not.
But that's not the way it has to be done, right? What will you learn by doing that? You should connect multiple ICs together. Go to the lab, whichever lab supports it. Go there and try it out. Make some chip. It's your hobby ideas. When you're in college, there's a magazine called Electronics for You. Lot of hobby ideas we used to those kind of hobbies. Have you used solder iron? You know what is soldering? Raise your hand and talk.
Yes,
Right
sir.
person. Yeah. Have you used it? Okay, Srivatsan expert. Okay, good.
Yes.
Okay, so what is soldering?
Connecting to discrete components like by
Yeah.
heat.
No, not connecting a component in the board, in the PCB, right? You are soldering the component into the board. The board already has a metals fabricated, right? Correct? Have you seen a PCB, bare PCB without assembly? Go to Google and see. Right? It's an outdoor course. I cannot teach. If you're interested, Arvind has seen it. So take a bare PCB without touch component assembly. Very good. Yeah. So take a bare PCB, right, and look at what it will have only metals and it will have wires or some holes. Then you have to assemble a component on that, right? So you should do that. I'll take you to some place and show you if you're interested. Before you go to AT, you should see that first. In the college, you have such thing. Ask Ashwin. He should be doing all this work, actually, right? I don't have to take you outside. Get out of Ashwin. He does all such work. So Vikrant, can you take an action talk to Ashwin?
Yes, sir, sure.
He has a lot of PCB. Take to bare PCB. How he assembles the component on the PCB, and how is he testing the PCB? 3 questions. On your own interest, whenever you have time, do that. No action item. Just if you're interested, you do that. Okay. So there is broken wires in the PCB. So the wires already fabricated. The metal lanes are there, and that is broken during the fabrication of the PCB. Let's talk about the PCB, then we'll apply that to the chip later on, right? So there's a wire which is broken. Right? By the way, Ashwin is part of the classroom. He's going to observe all our videos. So he's already part of the classroom as a teacher. Okay. So he's going to help us in a big way. So you will see this video. Okay. So there is a cut happens during manufacturing process. It's possible. There's a process called etching. Have you heard the name etching? ETCHING. Etch. Yeah, what is the etch?
Yes, sir.
What is it? Etching means. ETCHING. Etching is a process of fabrication. You mask it and remove the unwanted portions, right? So then what portion you want, it remains. That's how you form the metal wires, right? Go and check the Google. Do you have a course on IC design and manufacturing?
It removes the photoresist, sir, like etching.
Very similar to that. Very similar. I think MTech students will have a course on fabrication, design and fabrication this semester, next semester, I don't know, right? That's why the wires are broken, so it's not connected. Shorts. So what is a short? We have to go for maybe 20 minutes. We are the ones first slide itself. What is the fundamentals? What is a short? Don't tell a short what we wear, in your hostels, not the short. In electronics, what is a short?
So zero resistance.
Raise the hand. Please raise the hand. So I know who's talking. Yeah, Abhishek.
Zero impedance.
Okay, so how does that happen? See, I'm asking the same WH questions. What we spoke yesterday. I'm asking questions I want to make you think.
It happens when there is no potential difference between 2 points. Then we can call that it is short.
Give me a simple example. You're going roundabout.
Like 2 ends of a wire, a straight wire is a short.
That can be happen. Just VCC and ground are shorted. Correct?
Yes.
What happens?
Yes.
The fuse will blown. 5 volts and 0 volts are shorted. What happens? Have you tried that? You have to talk honestly. I've done that. I've burnt chips. Be honest. If you're not doing that, you're not an engineer. You have to burn. If you know, how many of you learn cycle without falling down? Raise hands. If you don't know cycling, it's okay, leave it. If you know how to drive without a supporting wheel, right, how many have learned cycle without falling down? So how many of you learn cycle by falling down? 1, 2, 3, 4. Oh, very good number. 5, 6, 7, 8, 9. Very good. Super, lower the hands. Very good. Very good. So you have to make mistakes, right? That's what I'm telling. So don't worry. Our faculty still don't know you have to be perfect. Don't make mistakes. I tell you, make mistakes. That's how you will learn. Without falling from cycle, you can learn. Yeah, you can learn, but you need a supporting wheel, right? So you have to make mistakes, ask questions, make mistakes, and we learn. If you're cooking, same way, you have to burn your hand, burn your fingers. You're cutting a vegetable, you have to have a bruise in your hand. Then you know, right? You have to make mistakes. To err is human. And the proverb says, right? You have to make mistakes. If you don't make mistakes, you are God. We are human beings, right? So you have to make mistakes. So short, I've done shots multiple times. You are not done shorting, you're not an engineer, right? I'll go and ask Ashwin how many times he has shorted. Shorting between VDD and ground or shorting two wires, as you told, right? Two ends of wire, two different wires going in parallel to each other, that is a short, right? And open resistive wire, what does it mean? What does open resistive wire mean? What does open mean? When you don't know some word,
Infinite
right?
impedance.
Break it into parts. Open, what is resistive, what is wire? You know what is a wire? What is open, what is resistive? Then you connect together and make a meaning. That's how you'll have to understand, right? Open, resistive wire.
Infinite impedance.
Very good. Give me an example.
When circuit breaks, no, sir, like open circuit, that's why infinite impedance.
Very good. Very good. Open circuit. Very good. And next is transistor defect. What is a transistor defect?
Transistor doping defects or
The chip
high
has a,
voltage issues. Or
yeah, I'll tell you. The chip has billions of transistors, right? Your chip, billions. How many billions? I don't know. You have to open a particular chip and see. Yeah, particularly you should see. Open a chip. If you have microscope in the institute, open up a chip with Ashwin's permission. Open a 74LS00 chip or 71LS04. You have a few rupees. Or you buy a chip. Go to Richie Street or buy it online. Buy a chip. Open it up. Remove the packaging. If you have a microscope, do it. Or go to Google it out. You'll see a lot of images. Right? Ask for Google for to show. There will be a lot of YouTube videos must be there. Right? Whether you do it yourself or you do it yourself. There's a keyword. Please underline. So that's extremely important. You have to do it yourself. Right? Can I do it? CID. How many of you have seen a series called CID? Oh, very good, man. I love you. So, what is the CID series? What is the summary in 2 lines? How do you describe the CID series? Vinash.
crime investigation and solving the case, sir.
So, tell me 1 line. You have to tell the whole story. Or it's like a trailer. 1 line or 2 lines.
When a crime happens, the department go to there and investigate about the problem and solve the history behind it, sir.
Very good. Very good. Right. Have you seen the complete web series?
No, sir, I've seen only one episode. That's why.
Okay. I've not seen it. I've heard about it. I have to find time to see it. Very good. Right. So, CID can be written as Can I do it? CID. Right. Investigation is one thing. Can I do? Right. So, can I do? Can I do testing? Ask yourself and raise the hand. I think the answer is yes.
So we can answer that question only when we start doing it. We can't answer
Yes,
it now.
exactly. So what prevents you from start doing it? Busy, right? Busy with social media, Instagram, playing games, club activities. Correct, right? Be honest, right? Very good. You have to be
Yes,
busy,
sir.
right? But you know what your
Proper
priority.
thinking happens, sir.
Yeah, you should know what your priority is. Everyone has only. Isaac Newton had 24 hours, right? Narayana Murthy has 24 hours. Ratan Tata has 24 hours. Nobody has 25 hours, right? I have 24 hours. All of us have 24 hours. Every living being, non-living being, everything, right? But how do you make, how many hours you sleep, how many, priority, right? You decide your priority. What is your focus? What do you want to become in the career? Ask yourself. I'll help you. If you don't know, I'll be happy. That's how you have to start. As I say, you would have read my LinkedIn articles. I don't know anything. I don't decide. That is my theme. So what does it mean? You know everything. You decide. I think we spoke in the first interactive meeting, right? Okay, so let's get on. So importance of testing. Why is testing important? What is testing we are seeing? So why it is important? We indirectly discussed. So can any one of you say why is testing important? Raise your hands. Yeah, we can.
To save companies' reputation.
Same.
To save companies' reputation.
Okay, good answer. Any other possible answers? Rutvik?
So to ensure that no faulty products enter the market,
Very good.
like
Very good.
if
So the
there's a
same.
faulty product, then
Yeah.
results might be skewed.
The same. It's kind of complementary or it's equal to the first answer. Reputation of the company. We have faulty product. Right? Say I'm an Apple. I'm a Steve Jobs. I make a faulty phone. One drop of salt go to the milk of whatever is the vessel of milk. What happens?
Entire milk spoils.
Absolutely. That is importance of testing. Right? Okay, now let's see. Okay. What is Moore's law? It says here. Who is a Moore? What is his full name?
Gordon Moore, sir.
Okay. What did he do?
Like he predicted like the number of transistors in an IC will get double. The count of the transistors will get double every 2 years.
Yes, every 18 months roughly, right? And unfortunately, we lost him a few months before. Gordon Moore, right? He passed away at the age of 90 plus, a few months before, month of April, May time frame, I believe. Correct? So that is Moore's law still valid or not?
Yes, sir.
Yes, still valid, but
Yes.
not 8 months, 18 months, sir.
Yeah,
Now
how many
every 12 months also now it is scaling like it is.
Can you get me the data? I'll be interested to see. Can you show me a graph or a data to show that from 2 years to 18 months to 12 months it's coming? You have a graph to show that. How the
But I
transfer is changing.
yeah, but we have a real example, sir, like in our scenarios.
Okay.
Can say like just last year we used 3 nanometer designs.
Okay.
So within next 8 months, we are planned to make it like it's a 2 nanometer device. So we can say like the 18 months he predicted like in a long back, it is the scenario, but
But I want to see a data. Forget about 2 nanometers. Don't talk company information in these meetings. Getting recorded. Go to YouTube public videos.
yes, that's fine.
They'll AMD find a lawsuit against you. Okay, be careful. I don't want you to do this job. Right?
Yeah, that's fine.
These meetings are getting recorded. Right? They go to YouTube public.
Yes.
Right? So be careful. Okay. Maybe I'll make this unlisted video. So I don't want to get into trouble.
No problem, sir. It's like it's already revealed to the.
No, but you're revealing the technology names and all, right? You're not supposed to do that.
No, technology is revealed because the next gaming chips, whatever it will come, we need to reveal.
Whatever is in the AMD website, you talk about it.
Yes.
If it is not in the website, you should not talk about it. Please be careful.
Yeah, that will be must meet.
Is it okay to make this video as a public or no?
Yes.
Okay. I have your permission. Okay. So can one of you, if you're interested, your research work, right? So plot a graph or see within ask ChatGPT or go and ask the Google, right? Get the correct data. Look at Gartner, who's a Gartner, right? Or ask me when I'm free, just ping me in Telegram if I have time. Then I'll work with you, right? Or you keep it in the bottom of our bucket. Make a priority list. How did you say priority? You have a lesson task, then you assign priority, and that's why I write every day a list of tasks what I do every day. So that in my mind when I get up. When I sleep, I look at my list of items in the bucket. How many I completed, how many not completed. You want to do many things, but priority decide what you have to do, right? If my daughter calls now, I have to take the call. Right? I cannot say I'll talk to you after 1 hour. Right? Maybe important thing, right? I don't know. My boss, the client calls, I have to take the call. Typically, I used to put my phone in silent in the last semester. Now I'm not putting it in silent. Right? I get a call, I have to take the call, say I'll get back to you, or I can have to talk for a second. Right? So I cannot do that because I'm in industry. Okay. So see if we can get a graph. It must be there internet. Look at Gartner. Can get a quest. So a lot of surveys will be done. Take a 3-year-old survey. You don't have to pay anything. Look at how the technology was scaling. Right? Number of transfers scaling. So that should be the answer. Okay, so I'll skip all these things. Yeah, feature size detection, I think Shankar spoke about it, right? So micron to nanometer to picometer to femtometer, it's going to come, right? Understand? Know what is a micron? Know what is a nanometer? After nanometer, what?
Armstrongs.
No. Nano, micro, nano,
Pico and femto.
Pico
pico,
femtos.
femto. Exactly. So you're going to go to pico and femto coming years. You're in nanometer, 2 nanometer, right? So what happens after that, 2 years down the line? So 0 nanometer, you cannot go, right? You go to pico, you'll got 100 picometer or 50 picometer, correct? Agree or not? I worked at my first device I did in Qualcomm is 90 nanometer design in 2004. When I quit, it was 4 nanometer design, 6 nanometer, 8 nanometer, 4 nanometer design. I had to go and check what 28 nanometer is what I have done. Mobile devices they were already working at 4 nanometer when I quit in 2019. Then a test chip. Right? It's all public now, I can tell. So in 2004, when I joined Qualcomm, it is 90 nanometer chip what I worked on, the first chip in Qualcomm. When I was leaving, I was working on 28 nanometer chip that is for a wireless segment. You can watch all the videos which are in the public domain. Right? Or find a slot, my free slot, I'll talk to you in the working days between 10 to 5, find a free slot, we can talk about it. Right? Or come, let's go for a dinner sometime over the weekend, let's talk about it, whatever you want. Right? So when I quit, Qualcomm was working on a 4 nanometer test chip. They want to public domain, I can see, right? So in 2019, they're working on 4 nanometer. Okay. Now they are going to pico and femto. Okay. Operating frequencies, the scale from 108 in 1970 to 108 kilohertz, the first microprocessor. What is the speed right now? What is the latest phone speed? Take iPhone, latest iPhone 14. What is the CPU speed or GPU speed? The iPhone or highest
So in
iPhone.
gigahertz.
How many gigahertz? The answer is here, it's a gigahertz. No, you don't have to tell me that, right? How many gigahertz? 5,
So now
10?
CPUs are coming at 2.4 gigahertz.
No,
And
man. How did I myself have done 2 gig and Qualcomm 5 years before. Don't tell me that. Telling a cutting
10
edge
gigahertz.
phone. What? 10 gigahertz. Which phone?
Not phones, like Intel's i9 processor operating.
We are talking about a phone. Okay. That is what it's server market, right? I accept. 10 gigahertz, does accept. So what speed the memories work? DDR memory. LPDDR is the latest standard. So you have to be aware about what is happening in industry, right? What does industry do? What is industry? And how do you know information? Go to company
sir,
website.
RAM would be like in megahertz, right?
Which one?
RAM, like DDR.
No, it is gigahertz. Gigahertz. Look at the latest LPDDR data sheet. Go to micron.com. Right? Look at the latest data sheet. Micron. Okay? You can take an look at it and post it in the Telegram group. Let's go forward. Okay. So if you look at this very important point. We have 10 minutes time. What this bullet says, I'll not read as I said. You have to read yourself and tell me what is it. Very important point. Please write down. So what does that line mean? Please raise your hand. Any answer is okay. You have to interact. Yeah, Vikrant.
Sir, as the size of the chip reduces, sir, uh, there will be an increasing chance of that the chip will not work if there is a defect.
Very good. What does the next line do? Yeah, you read it yourself. I'll skip. We'll run out of time. See this bottom line. Do you know what is the bottom line in industry? You say bottom line. What does it mean?
Conclusions.
Sorry? Sorry? When you say bottom line in industry scenario, you're not in industry, but imagine what is the bottom line in industry? In any business, forget about electronic, any business, like your textile business or any business, right? Or an ICICI bank or Kotak Mahindra, any bank, any business. What is called bottom line? Is anyone good in economics here? You want to become, how many of you want to become entrepreneur? Wow. One hand went up, it went down. Joseph, okay. Very good. Anyone else? That's all. Oh man. Not now, after 10 years in your career, how many are you entrepreneur? How many? Okay. Rakesh, very good. Joseph, Arvind, very good. Excellent. 4. Tarun, okay. So what is the bottom? You should know what is the bottom line. Okay, I'll teach you. We'll talk about entrepreneurship later. Right? Bottom line is your profit and loss. That is the bottom line of a company. Right? So that is the bottom line of this slide. That is the crux, the summary of this slide. Just one faulty transistor wire can make the entire chip fail. How a salt, simple one piece of salt, what do you call one tiny drop of salt falls in a vessel of milk, makes spoils the milk, right? One transistor having a faulty one transistor wire can make the entire chip fail at the required operating speed, or some issue will happen there. We can always work around that. We'll see that later. So that's how it is, right? What happens? You put a salt in the milk, it's spoiled. Can you make use of it? You cannot drink it, but can you make use of it?
We can use it to make biscuits or some bakery.
Yeah, sweet, tooth peda, right? Or some kind of some sweet, something you can make out of it, right? Some sweet you can make, a milk sweet you can make out of it. Some form it can come, whatever it is, right? You don't throw it, right? So that's one, right? So profit and loss. Industry has to make profits. Qualcomm made loss in the last quarter. You can look at the Qualcomm website. Every company is making loss. They have to turn around. If they don't turn around, they'll start firing people. Yesterday I spoke about cool firing people. I changed the topic immediately, right? Sundar Pichai will file a lawsuit against me to say that. Right? So your P&L has to be positive for always your investors will question you. Right? You're continuing, who is your investor in your career? You're all studying, right? 3rd year, 4th year, masters and PhD. Who is the investor for you?
Our parents.
Very good. So what is the P&L for your parents? Why are they investing in you?
Out of generosity, sir.
Sorry? Don't tell me they have a lot of money they're investing, right? Sorry.
Generosity.
Generosity. No, wrong answer, man. Wrong answer.
So that we take care of them, they get.
No, wrong answer. How many parents are in old age home today? Let's not go there. Sorry. It's not a. There's one reason. Where did you go and ask your parents this weekend, right? Call them. You must be talking to them once in a week at least, right? Call them. Why are you making me study?
So that we have a secure future.
You are self-sufficient, self-reliant nation. I spoke about it, right? One of my friend is he's reading Marvel Semiconductors India, right? His name is Naveen Bishnoi. He posted a message August 15th. Go and look at what I replied to this message. You want self-reliant nation. You have to do everything on our own. You have to stand on your own leg at some point of time in your career, right? Take care of parents, everything may happen, may not happen. Don't worry about it. You have to take care of yourself. If you have a flight, right? If there is a problem, what do the announcers that will take off? You put your seat belt, you put oxygen mask in emergency, then you help others. Right? You have to protect yourself. Right? So that's the bottom line. Okay. So I'll not read out all this easy. Same thing. Testing is required to guarantee fault-free products. You already spoke about it, right? Also necessary to test various. What does this mean? Can one of you paraphrase that? What are the various stages of manufacturing process? You have to understand that. Generally testing components. Let's look at the product, cell phone. So what are the various stages of manufacturing process of a cell phone? Forget about chip. Chip manufacturing process none of us know, including I studied it probably in 1992 when I was in college. So I know. Somebody asked me, please help on manufacturing. I told I myself don't know how to manufacture. India doesn't know. One of the colleges I spoke to yesterday, I'm talking to a lot of people. I tell how I have not done manufacturing with 32 years of career. I did my bachelor's in 1991, right, and master's in 1993, right. I don't know. I studied in 1992. I fabricated a CMOS device, some resistor. I don't know. I had to go back to my IT Kanpur and see. All my friends what I manufactured. They told me something. I had to go and ask. My best buddy is in Intel. US. His name is Ravi Chandran. He replied something. I fabricated something, some transistor, some resistor, detector, something I manufactured in 1992. IT Kanpur campus. I forgot what it is. So if the faculty is still alive, I want to go and ask him. Or I'll go there and ask what they are doing. I'll go and visit. After I'm going to Delhi, I'll go and visit for a day in IT Kanpur. Okay. So how is any device, any system manufactured? Mobile phone, TV, washing machine, any electronic gadget. Or take anything, food. Let's take a non-technical example, right? There's a process, as we spoke about, right? About Maggi, right? The traditional way of cooking Maggi, we spoke about it. There's a manufacturing process for a Maggi, right? One of you told about that. So how do you test during various stages of Maggi, cooking of Maggi?
Surrounding conditions, sir.
Give me an example, man. Don't tell surrounding conditions. So we have to talk about
Like
Maggi of Maggi, traditional way, 10-minute cooking, right? How do you check you're doing everything right? Well, cook any food. Maggi is one, but you can make roti, like whatever, right? Side dish, pulao, biryani, whatever, right? Aloo paratha, methi paratha, whatever, right? Sambar, rasam, South Indian, whatever. Any food, there's a process to make, as we said yesterday, right? How do you check? How do you test? Why do you test during various stages of the manufacturing process for a food?
So we can use sight and touch, sir. Like when cooking Maggie,
Yeah,
we'll try.
smell, color, taste, right? Three important things, right? Smell, you can smell it. You can see, look at the color. You can look at the taste. You can taste it once in a while. Not just Maggi, any food you cook, right?
Also, how soft it is.
How soft, yeah, texture, we add it, yeah, right? So there are various things. So the same way, there are various stages of manufacturing process. You have to test them, right? It's important. Okay, look at this line. I'm not. You read yourself. And you paraphrase again. You have to tell. I want to learn from you. What do you understand? We have 5 more minutes to go.
Sir, it is easy to correct the defect at the earlier stage. Like if as a whole product, if we divide into different subsections, like at each stage, the cost of the defect it is very less compared to the whole. As a product as a whole, if you find a defect.
Okay. And you understand this example? There's an example here, right? The cost goes by 10 times. Let's take one of the food item. What I will take? Veg biryani, tandoori chicken. What example you want to take? Some complex food. Pick up any food item. Since we talk about Maggi, right? Maggi is simple. What is the common food item we all like here in the class? Veg, non-veg? Biryani, Hyderabadi biryani. Like Hyderabadi biryani. A lot of people are from Andhra Pradesh here, I know, right? Have you tasted Paradise? There's a place called Paradise in Hyderabad. The biryani is very famous there. I lived in Hyderabad for 11 years. Have you tasted Paradise biryani? No one. Okay, Avinash. Very good. Where is Nikit? He's not there. Nikit is absconding. Asha, you need to take attendance. Asha, if you are there.
Yes, sir. Yes, sir, I've taken some.
Okay. So, if you make a biryani, so there's a process. Every time you make a mistake, if you can correct at the earlier stage, you can get close to biryani, it can come, right? But you make the last final stage, you make a mistake, you have to throw the biryani, correct? Right or wrong?
Correct.
Very good. So anything, we can apply to textile, any industry, electronics, any food, textile, or it applies to all the manufacturing, any process. anything you manufacture or factory, right? So cost in electronics is cost of 10. In the food industry, I don't know what is the cost. It will be more or less. Make a study, right? So that's how you have to relate, visualize. Right? So you have to visualize what you are reading with. When you understand the concepts, then you can apply the concept. We are learning concepts. Very soon we'll learn how to apply this concept. This course is all about concepts. You are learning concepts. I'll give assignments to ask you to apply these concepts. Okay? Or you yourself decide what assignment you want to do. Free assignment. Whatever concepts you learn. So every 4 weeks there will be assignment. There will be 16 weeks, right? So month of September there's one assignment. October, November, 3 assignments will have. Some exams will come. 3 assignments is more than enough. We'll make it for whatever marks, 15 marks each, whatever you want. So let's decide that, right? So we'll talk to me in the Telegram group. 3 assignments, let's keep 3 to 4, not more than that. And you do your own assignment. Whatever you learned in that month, you write, you use a concept, you apply the concept, you make assignment on your own and submit it. Write a paper, which will be your concept, what concept you learn, how do you apply the concept in this particular domain. And you use examples as much as possible. A short research paper, all right? So let's do that as that's assignment. Are we okay? How many hands go up? Let's see.
Yes, sir.
Raise the hands. 1, 2, 3, 4, 5, 6, 7, 8. Wow, that's majority. 10, 11. Wow. So my job becomes easy. I don't have to define assumptions, right? So Asha, you can post in the classroom on my behalf these assignments. We'll have 3 assignments. So let's not trouble students. One in the last week of September, one in the last week of October, one in the last week of November. 3 assignments. And they can write whatever they learn in the last 4 weeks, they can learn from August 20. Let's make it 21st. Class on August 21st. So it will be due on September 21st, right? October 21st, November 21st. That's all 3 assignments. December 11th, your exam. Last 3 weeks, you leave it. And all other courses will go crazy giving assignments, right? So also you can create in the assignment section 3 assignments due on September 11th, September 21st, October 21st, November 21st.
Okay, sir. I'll post it here.
Yeah. 3 assignments. Whatever marks you want, you assign it. You scale it to 40 if later on.
Okay, sir.
Everyone can decide whatever they wanted to do them right. You can validate it, right? So, okay. But it should be about concepts, application of concepts. What concepts they learned in the last 4 weeks, how they apply the concepts, and they have to use examples.
Okay, sir.
Okay. I got this easy. Okay. So this is what is this electronic system? This is the last line, man. Electronic system. ICs assembled on PCBs. PCB assembled as a system. You can relate that to my video what I posted, the system on a chip. You can look at a carrier opportunity VLSI design. It's that in the YouTube, and I would have posted the carrier section in the Telegram group. You can look at what is the system. I would have defined it there. Carrier opportunity in chip design, system on chip design. Look at that video in the I posted. It's there in the class. It's there everywhere. Go to YouTube and you can search. If you don't find it, let me know. It's in the class, right? So we'll stop here. Any questions? 1 to 2 minutes. 10:49. No questions, guys? Okay, class dispersed.
What is fault, sir?
We'll come. Hold on. Next class. So Monday, Tuesday, there is no class. So if your record video will become non-interactive, right? What do? Ask questions, leave a pause for a minute. You have to pause. I say pause the video. You pause the video, you think yourself, right? And write down the answer, you can post in the classroom. Will it work? We had a very interactive session, right? So I'll say pause the video. You have to pause the video then. You think about it, take notes. I'll say, then after a minute, you can resume the video from there or whenever you want, right? That's how we make interactive in a recorded video, okay? When you say pause the video, you pause the video, think about it, then whenever you are ready, play back the video again, okay?
Yes, sir.
Thanks, guys.